Hi everybody, today we'll be working on section 4.4. We'll be dividing polynomials. We have two methods of dividing, sort of like we had two methods of evaluating back in 4.1. And the first is polynomial long division. Okay, in order to divide using polynomial long division, we set up our problem. We put the guy we're dividing by on the outside. And then this guy on the inside. Okay, if we were missing a term, actually like we're missing an x squared term, we put a 0x squared in there. And we're good. Now, to divide using polynomial long division, we basically say to ourselves, how many times or what would I multiply this first term by to get this first term? So to get 2x to the fourth from x squared, I would multiply it by 2x squared. So I'm going to put that in front there. Then I multiply. 2x squared times x squared is 2x to the fourth. 2x squared times negative 2x is negative 4x to the third. And 2x squared times 2 is positive 4x squared. Then my next step is to change all the signs. Make this negative, this positive, and that negative. Okay, then I add. 2x to the fourth minus 2x to the fourth cancels, and that's your goal. 3x to the third plus 4x to the third is 7x to the third. 0x squared minus 4x squared. Then you drop these guys down. Plus 5x and minus 1. Now we start all over. Okay, what would I multiply x squared by to get 7x cubed? And that's positive 7x. So then I multiply. 7x times x squared is 7x to the third. 7x times negative 2x is negative 14x squared. And 7x times 2 is positive 14x. Now we change our signs. Make this one a negative. And add straight down. Those are gone. We get 10x squared minus 9x. Drop that down, minus 1. And we do it one last time. To get 10x squared from x squared, we have positive 10. So then we multiply. 10 times x squared will be, oops, I'm sorry guys. 10x squared. 10 times negative 2x is negative 20x, and 10 times 2 is 20. Then we change those signs, negative, positive, negative 20. And we add. Those cancel. We get 11x minus 21. Now, x squared could never multiply to be 11x, so that's sort of how we know we're done. Our answer here would be what we wrote on top, 2x squared plus 7x plus 10, with a remainder of 11x minus 21 over that original x squared minus 2x plus 2. Okay, and so that's the process we're going to use as we do long division. Fortunately for us, we don't have to do much long division. Instead, there's a shortcut way called synthetic division that we're going to use. And this is sort of why we learned synthetic substitution, is because we need to be able to use synthetic division in order to divide. So if we look at this, we're going to be dividing x cubed plus 2x squared minus 6x minus 9 by x minus 2. Okay, what we're going to do is we're going to solve for x minus 2. So we add 2 over and we say, okay, that means x equals 2. So I put 2 on the outside. Then remember, we line up our coefficients. In front of x cubed is a 1. In front of 2x squared is 2. then negative 6, and negative 9. We drop down the 1. 2 times 1 is 2. Add straight down to get 4. 2 times 4 is 8. Add straight down to get 2. 2 times 2 is 4. Add straight down to get negative 5. Okay, now we use these numbers below to write our answer. Okay, we always start 1 degree less than our original. So this will be 1x squared plus 4x plus 2. Then that negative 5 is our remainder, so that goes over top of the x minus 2. Okay. Then we are going to do the same thing, but with x plus 4. So here we've got x plus 4, so we know x will be negative 4. So we'll put a negative 4 on the outside. Then those coefficients were 1, 2, negative 6, and negative 9. We drop down our 1 and get negative 4. That becomes an 8 when we multiply, so we get 2. This becomes negative 8, so negative 17. Just like last time, we rewrite this 1 degree less, so 1x squared minus 2x plus 2 with a remainder of negative 17 over that divisor x plus 4. Okay, we have one more example of synthetic division. Here we solve for x. We'll get x is negative 2. So we're dividing by negative 2. So we have 1, negative 3, negative 7, and 6. When we drop down the 1, we get negative 2, which is negative 5, positive 10, 3, negative 6, and 0. What that means when we get a remainder of 0 is that this evenly divides into x cubed minus 3x squared minus 7x plus 6. So our answer here is 1x squared. We could just write x squared minus 5x plus 3. You don't have to write a remainder if that turns out to be 0. Okay, then over here we're dividing by negative 3. And we had 1, negative 3, negative 7, and 6. Okay, this one's a little different. It ends up with a remainder, so we have x squared minus 6x plus 11 with a remainder of negative 27 over x plus 3. Okay, so that's synthetic division. Now the reason we learn how to use synthetic division is in order to start to factor if we can't factor from the original function. So just to review, a polynomial f of x has a factor of x minus k if and only if when we plug in k we get 0 if it's divisible. So if we wanted to factor this, we would say that's just a trinomial, so it's going to be 2 factors, x and x. Our last 2 must multiply to 2, and I would guess they're both going to add. Remember to check we FOIL our insides and our outsides, and those do make 3x. Okay, now remember that we can say a factor, or it is a factor if when we plug in our solution, so our solutions here would be negative 2 or negative 1. If we plug those in, we get 0. That's just a property of them being factors. So if I tell you a 0, you can rewrite it, right? If I told you this was our 0, then we would say that means x plus 2 is a factor, and x plus 1 is a factor. Okay, so now if we're going to factor using this factor theorem, this says f of x equals our polynomial given that negative 3 is a solution. Okay, if I know negative 3, f of negative 3 is 0, then I know x plus 3 is a factor. okay? Our hint here is to use synthetic division to find the other factors. So I'm going to divide out that negative 3. We get 2, 11, 18, and 9. So negative 6 and 5, negative 15 and 3, negative 9 and 0. And I should get 0 there because this is a factor. It divides evenly. Okay, what this means is I'm left with a polynomial 2x squared. I go 1 less than the original degree, plus 5x plus 3. Okay, now this is something I can factor, and then I'll be done. I'm factoring. So to get 2x squared, I'll say 2x and x. To get 3, I'll say 3 and 1. Let's say I put my 3 there and my 1 here, both positive. Now if I FOIL, my insides get me x, outsides get me 6x. Those combine to be 7x. So maybe I need to flip-flop these. 3 there, 1 here. Now I get on the inside 3x and on the outside 2x, which adds to that 5x. Okay? So my final answer here will be this original factor, x plus 3, then my final 2x plus 3 and x plus 1. Okay, excellent. Here's another one. Now we're given our factor. If I'm given a factor, then I just solve in order to divide. So I'm going to divide out a negative 4 with my coefficients 3, 13, 2, and negative 8. I drop down the 3, which gets me negative 12, 1, negative 4, negative 2, positive 8, and then that 0 that we would want. Now when I rewrite this, I have 3x squared plus x minus 2. Okay, to factor that, I'll say, I know I have 3x and x, and I have to multiply to negative 2. Maybe 2 and 1, negative and positive? Let's just see, okay? This is negative 2x. Here I have positive 3x. Those add to 1x, which is what I wanted. Okay, so now my final factors are that first one I was given, x plus 4, 3x minus 2, and x plus 1. Okay, so synthetic division is really important because it helps us factor polynomials that would not have been factorable before. If we look at both of those, they were 4-term polynomials, so we could have tried to use factor by grouping, but we wouldn't have been able to because 3x cubed and 13x squared and then 2x minus 8, you couldn't pull out a GCF from both of those groups, which would leave behind a matching set of parentheses. Okay, here's your exit ticket, just 4 questions. Let me know if you have questions, and